Okay? All right. Now the last idea is entropy and Gibbs. So 13, arrange the three states of matter based on increasing entropy. Remember, the symbol for entropy is delta S. The other thing that I would remind you is that the R in entropy, okay, not only does it tell us that S is the symbol because S comes after R, but also think of R as standing for random or disorder. That'll help you remember what it means. So entropy, or delta S, is a way of describing the disorder of a system, meaning a closed reaction. Okay, so the disorder or randomness of the three states of matter are such, for increasing entropy, solids have less entropy, meaning less disorder. Another way of saying it is they're more organized than liquids, which are more organized than gases. But the way we wrote it is solids have less disorder than liquids, which have less disorder than gases. Okay, so gases have the highest entropy, they're the most random, they have the most disorder. Solids have the least. Okay, fill in the chart below, delta G. If the delta G of a reaction is positive, no reaction. If the delta G is negative, spontaneous, or what we call yes reaction. Okay, if the delta G is at 0, it's at equilibrium. Okay, last two problems. So we're looking at question 15. Is the following reaction spontaneous, assuming that delta S equals 0.4143 and at 25 degrees Celsius? The big thing to remember here is that your temperature can't be in Celsius. You got to convert to Kelvin first. So we do 25 plus 273 is going to give us 298 Kelvin, right? So now we can plug it in. The formula is delta G equals delta H minus, don't forget that minus sign, T delta S. So we plug in our numbers here. We've got the whole reaction, right? Here's our delta H. So it's going to equal negative 397.7. Just plugged my delta H in there. Got my negative 397.7 minus, and we figured out the temperature is 298. So 298 times the delta S, which is 0.143. Okay. Now I left my units out. That's because we're not really dealing with the unit calculations here or cancellations in this particular unit with Gibbs. It's one of the few areas where I'm not going to ding you on your units. Okay. So I guess you can relax about that. But you do need to pay extra close attention at signs. So double check your signs before you do your math. So notice my delta H is negative, temperature is positive, Kelvin is actually always positive, and then for my delta S, always double check what its sign is. So in this case it's positive. Okay, so now I can do my math. You have to multiply these guys first. You can't start subtracting yet. So I suggest multiply these guys out. So this is going to equal negative 397.7 minus, and then I do 298 times 0.143, which is going to give me 42.6. I'm rounding. So now we can plug it into our calculator and we can say 397.7 negative minus 42.6 is going to give me negative 440.3. So this number is your calculation. What's really important about this number is the sign, which is again why I say you have to double check your signs, because the most important thing about these answers is what the sign is. Because then we go back over here and we say, okay, the delta G is negative, so reaction occurs. Okay, so we know that that reaction occurs. So now we do the last one, 16. So it says calculate the delta G for the following reaction at 25 degrees Celsius, blah, blah, blah. Okay, so again, 25 degrees Celsius, we're going to change that to 298 Kelvin, just like we did up here. I'm not going to do the math because we already did it, 25 plus 273. Okay, now we plug it into the formula. So our delta H is hiding right in here. So delta G equals 28.05 minus our temperature, which is 298, right? I got that right here. I had to turn 25 into 298, times the delta S, which is 0.109. Again, double check your signs. So here's my H, okay, positive there, positive there. My delta S, positive here, positive there. You don't have to check the sign of your temperature because it's always going to be positive, okay? So then I do my math, so it's going to be 28.05. I'm going to combine these two together, so 28.05 minus, and I'm going to do 298 times, whoa, messed it up, 298 times 0.109 is going to give me 32.48. Okay, if you want to round that out to 32.5, that's fine. Number's just going to be off by a little bit, but I have 2 decimal places here, so I'm going to go to 2 decimal places here as well. So I have 28.05 minus 32.48 equals negative 4.43. So again, the key to this is the negative sign, the fact that there's a negative there. That tells us that the reaction occurs. If you mess this up and you didn't do the sign right, then this would be positive, and you'd be like, oh no, it's not going to occur because it's positive, right? Positive equals no reaction. But because it's negative, we know there is a reaction. So the sign is the most important thing. So be careful when you plug your signs in. And remember, if this had been a negative delta S, this negative would have changed this to a plus. The negative would have gone away, and this would have became plus. And that would have changed everything, right? So make sure that you keep track of signs. Be careful with that. And we'll see you tomorrow for the test.